Our first important theorem in our study of calculus is the intermediate value theorem. And the reason it's in this section 2.3 is because the intermediate value theorem only applies to functions that are continuous. Or we could say it only applies on continuous parts of functions that might be discontinuous in certain other places. But for this to work, I have to guarantee that the function I'm working with, the part of the function I care about, has no skips and no jumps. So let's see what it says. If a function, f of x, is continuous, has to be continuous, between two x values a and b, then the y values, f of a and f of b, every single y value in between them and including them has to get touched by the function somewhere between a and b. So let's see what that means. Suppose I have a favorite y value and it's y equals k, pick some number, and I know that my favorite y value is somewhere between whatever this y value is whatever this y value is and this y value is. If I know 2 points on the function, a comma f of a and b comma f of b, and my favorite y value is somewhere between the two y values I know, f of a and f of b, then I can guarantee, I know for 100% certain that this function, somewhere between a and b, is going to have to cross or touch my favorite y value. So we can read that second sentence there too to kind of help us understand. If k is some y value, my favorite y value in the whole world, and it's between the two y values I know, then there's going to be at least one x value somewhere between a and b. There's going to be one x value, I'm just going to call it c, that if I plug c into the f function, I get my favorite y value out. So this is an example of what's called an existence theorem. The intermediate value theorem can promise me that this c value exists that I could plug in to get my favorite y value out. It doesn't actually help me find the c value or even tell me how many times it happens. All it can promise is that it happens at least once. So there exists at least one c value between a and b, which if I put into the f function, gives me k as an output. So here's an example of how you're going to see that on the AP test. It's going to be my recommendation that you make a little sketch every time you want to answer an intermediate value problem. It can help you keep your numbers in the right order. So suppose I have a function f of x that I know is continuous. Somebody's promised me, guaranteed me that it's continuous. And I know 2 points on this function. I know f of negative 1 is 2, so when x is negative 1, y is 2. And I know f of 5 is 4, so when x is 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, the y value is 4. Okay, I know these 2 points are on my function, and I know that my function is continuous. So I've been asked to explain why there must be a value c for which f of c equals 3. Notice the number they've asked me to care about is 3, and f of c is going to be the input, so that's like the x, 3 is the output, that's like the y. So I've been given a y value to care about. And, check it out, the y value I care about is 3. If I come through here and I draw in a horizontal line at y equals 3, here's what they're asking me. They're saying those 2 purple dots are on my function. If I connect those purple points with a continuous function, am I sure it's going to cross or touch the red line? So you could try to draw it in, and you'll probably come to the conclusion that yes, there's no way to connect those purple points that doesn't cross the red line. So that's what we want to use the intermediate value theorem to state. And the reason that works is because I know the function f is continuous, so I can't go jumping or skipping around. So I'm going to type up how you're going to need to phrase your response on the AP test so you can start to practice, and then there's 3 more practice problems on the back side of your assignment. That's for practicing writing up a solution, writing up a justification using the intermediate value theorem. So watch this. It's going to be our job to explain a little bit at a time why I know that my function, if I draw it in purple, is going to have to cross the red horizontal line. So we know it's true. This only works because I've been told the function is continuous on an interval. The interval I care about is from a to b. In this case, that's the two x values. It's always the two x values. In this case, -1 and 5. So I would start my justification by saying, since f of x is continuous on the closed interval, that's brackets, -1 to 5, and what else has to be true? And here's the next part. Because I know if I connect the purples, it's going to have to cross through the red line because I have one purple dot that's above the red line and one purple dot that's below, right? So f of x is continuous, and f of -1 is 2, which is less than 3, implying that point is below the horizontal line I care about. And f of 5 is 4, which is above the horizontal line that I care about. So I'd write f of 5 is equal to 4, which is greater than 3. Now I'll draw my conclusion. So since those first two things are true, I can make my conclusion. The intermediate value theorem guarantees that there exists C. C is between A and B, so I write A is less than C, which is less than B, for which f of C equals 3. Just notice here, here, and here, these are all the important y value, that y value I was interested in.